Hi students, I think this is the lecture for today. Today is Wednesday, 2nd of December 2020. You are still in the uh, chapter or topic for accounting for decision making. So I hope you still remember why you have to learn about this decision making analysis. It is because if you are working as a management accountant, you have to help manager to make business decision. So the logic is like this: before a manager wants to make a business decision, an analysis has to be done. If you make or if the manager makes a business decision without doing an analysis, most of the time the manager will make a wrong decision. Another way to think about this is like this: you have a business, let's say you have in the future you have a business, so every day you have to make many business decision. The simplest one is you have to make a pricing decision, and then you have to make decisions like you have seen in this chapter. So always remember, when you want to make a business decision, the best way to do it is to analyze the matter first. If you do not analyze the matter, most of the time you will not make a good decision. Okay, this is the next thing after you have the next thing after the decision that you have learned in the previous lecture. Let's see. Okay, in this slide, the first point is when a limited resource of some type restricts the company's ability to satisfy demand, the company is said to have a constraint. And the second point is the machine or process that is limiting overall output is called the bottleneck. It is the constraint. So the thing is like this: let's say you have in the future you have a business. The business is a manufacturing business. Most of the time, you will have something that is called a constraint. The constraint is like this: you have a machine, or maybe a process, or maybe the workers that is limited. You have used this machine or people or process at the maximum, so your production process cannot be increased anymore because of that constraint. So if you have that you have a constraint in your manufacturing business, then you have to use the constraint item in a way that it gives you or your business the highest profit, because in accounting the main focus is on profit. In accounting, the higher the profit, the better. If the profit is less, or if a business is making loss, then that is not good. Okay, so let's see. This is not very difficult. So let's see, in the yellow box, when a constraint exists, a company should select a product mix that maximizes the total contribution margin earned, since fixed costs usually remain unchanged. Remember, so the focus is on the contribution margin. Remember, what is the contribution margin? Contribution margin is revenue minus variable costs or expenses. A company should not necessarily promote those products that have the highest unit contribution margin. Rather, it should promote those products that earn the highest contribution margin in relation to the constraining resource. Later in the next slide, you will see that the product that has to be prioritized is is the product that can generate the highest contribution margin for a unit of constrained resource. Let's say the unit of constrained resource is machine hour. Then the product that should be prioritized in the production process is the product that can generate the highest contribution margin per machine hour, or machine minutes, or labor hour. Depends on the unit of the constrained resource. Okay, I think this is an example. So let's see. There is a company. That company produces two products, and selected data is shown below. Okay, see the products are product 1 and product 2. Product 1, the selling price is $60. Product 2, the selling price per unit is $50. And then variable expenses per unit is $36 for product 1 and $35 for product 2. Contribution margin per unit is $24 for product 1 and $15 for product 2. Current demand per week, this is customer demand, or the unit that can be sold. Okay, for product 1, the demand is 2,000 units per week. 2,000 units per week, yes. And then product 2, the demand is 2,200 units per week. Contribution margin ratio, 40% and 30%. Processing time required on machine A1 per unit. Product 1 requires 1 machine minute. Product 2 requires only 50%, or 0.5 or half a minute. Okay, now, if the machine... Okay, let's see the next slide. So now you can see here, product 1 has the highest contribution margin per unit compared to product 2. But the thing that you can see here is, product 1 requires 1 minute machine. Product 2 only require 0.5 minute machine, or 30 second only to produce. Okay. Okay, let's see. Machine 1 is the constrained resource and is being used at 100% of its capacity. So the business or the company has the company uses a machine called machine 1. Machine A1. Now, the machine is used at full capacity. It means that it cannot be used more than that anymore. It is at its full capacity. There is excess capacity on other machines. So, machine A1 is the constrained resource. Machine A1 has the capacity of 2,400 minutes per week only. Okay, the question is, should this company focus its effort on product 1 or product 2? Okay, if you can remember, you can see that product 1 has a higher contribution margin per unit compared to product 2. So if you do not do an analysis, you will say that, most of the time people will say that it is more profitable to use the machine to produce all product 1 first. And after that, if there is a balance of machine minutes, the balance can be used to produce product 2. Why? Because product 1 has the higher contribution margin per unit. That is the likely answer if you do not do an analysis. So let's see how to do an analysis and make this decision. Okay, for this decision on constraint resource, there are two steps. The step one is you have to calculate contribution margin per unit of the constraint resource. In the previous slide, you have seen contribution margin per unit for product 1 and product 2. But when you want to do analysis for constraint resource, the first step is to calculate contribution margin per unit of the constraint resource. So let's see how to do this. Okay, now you use the data from the previous slide. For product 1, the contribution margin per unit is $24. Product 2, the contribution margin per unit is $15. Okay. But for time required to produce 1 unit, product 1 requires 1 minute machine. Product 2 required only 0.5 minute machine. So now you calculate contribution margin per unit. Sorry, per minute. Minute is the unit of the constraint resource. Because the constraint resource is machine, so the unit for the constraint resource is one machine minute. So contribution margin per minute is for product 1 is $24. For every 1 minute machine use to produce product 1, the contribution margin that the company can get or can generate is $24. But for product 2, for every 1 machine minute, the company can generate $30 contribution margin. Why $30? Because for 1 minute machine, the company can produce 2 units of product 2. Because for product 2, 1 unit requires only 30 seconds only. So one machine minute can produce 2 units of product 2. So the contribution margin that can be generated is $30. So this is the first step. If you want to make decision for constraint resource, the first step is to calculate contribution margin per unit of constraint resource. So now you can see product 2 should be emphasized. Provides more valuable use of constraint resource, machine 1, yielding a contribution margin of $30 per unit as opposed to only $24 for product 1. After you do this analysis, now you know which product has to be emphasized or prioritized. If there are no other consideration, the best plan will be to produce to meet current demand for product 2 and then use remaining capacity to make product 1. So this is the next step in this decision making analysis. You have to show how many units or how many machine minutes has to be used for product 2 and product A. Given that product 2 generates the highest contribution margin per machine minute, this business has to produce product 2 first. So see the demand for product 2, the demand is 2,200 units. So 2,200 units, time required per unit is 0.5 minute. Total time required to make product 2 is 1,100 minutes. Remember, the machine has the capacity of only 2,400 minutes. So from these 2,400 minutes, the business has to produce all product 2. Because the product 2 is the product that can generate the highest contribution margin per machine minute. That's why the business has to produce product 2 first. After the business has used the machine to produce all demand for product 2, the balance of the machine hours or machine minutes can be used to to produce product 1. So 1100 minutes are allocated for product 2. The balance is 1300 minutes left. That 1300 minutes should be used to produce product 1, because the product 1 is less in term of contribution margin per unit of constrained resource. So 1300 units left. How many product 2 can be how many product 1 can be produced using the 1300 minutes left? The unit is 1300 units of product 1, because product 1 needs 1 machine minute for every unit of product 1. Okay, let's see, I explain it again. I try to make it simpler. Okay, the situation is like this. This is the sample question or the example. This is a business, and then you can see the selling price, and then variable expenses, and then contribution margin per unit. And then you can see the demand per week, and then you can see the contribution margin ratio, and then you can see the most important data, processing time required on machine A1 per unit. So product 1 requires 1 minute machine, and product 2 requires only 0.5 minute machine. So you are given this data. How to make decision about whether the business should focus on product 1 or 2. Okay, this is the constrained resource. The constrained resource is machine. The machine only has 2400 minutes capacity per week. So how to make the analysis? The first step is you calculate contribution margin per unit of constrained resource. In this question, the unit of constrained resource is machine minute. So you calculate for 1 machine minute, how much is the contribution margin for product 1, and how much is the contribution margin for product 2. After you have done this analysis, you can decide which product that the business has to emphasize. In this example, the product 2 has to be emphasized, because for product 2, the contribution margin per unit of constrained resource is $30, which is higher than the product 1. After you have identified the product that has to be emphasized, you prepare this table. This table will show how many units of product 2 has to be produced, and after that it will also show how many units of product 1 should be produced. In this example, 2200 units of product 2 can be produced, and for product 1 only 1300 units can be produced. Okay. This is the explanation. According to the plan, we will produce 2200 units of product 2 and 1300 units of product 1. Our contribution margin will look like this. Contribution margin for product 1 is 1300 units times $24. The total contribution margin is $31,200. For product 2, 2200 units times $15 the contribution margin is $33,000. So the total contribution margin for Ensign is 64,200. This is the highest contribution margin that the business can get from using the constrained resource. If you put it in another way, let's say you say that product 1 is should be prioritized. You can calculate, and then you will see that if the business uses the machine to produce product 1 first, then after that uses that machine for product 2, then the total contribution margin is less. This analysis help the business to make decision which product to or which product has to be prioritized. Okay, and then this is the explanation about constrained resource. If you have a business or you work in a company that has if you have a business, then your business has a constrained resource. There are several things that you can do. The first one is you can improve the process. Maybe after you improve the process, you can generate more product using the constrained resource. Or the second thing that you can do is you can ask your workers to work overtime. Let's say now you have a constrained resource. The workers use the machine during the day only. So the another way to make the machine can produce more is to ask your workers to work overtime, or you can create another shift of working hours. So you have a group of workers working during the day and another group of workers during the evening maybe. So if you do that, you can double the production hour. You can produce more. Or the next thing, point number 3 is you can hire new workers, or you can purchase more machine. If now your business only has one machine, so to increase to solve the problem of constrained resource, you purchase a new machine, so you can produce more. Or the third thing is you can subcontract production. This is a new thing. Many companies do this. Let's say their factory can produce only 3,000 product per week, but the demand is more. Let's say the demand is 4,000 unit. So one way to solve this problem is to subcontract the work to another company or factory. And then the number 1 2 3 4 5. Number 5, another way to solve the problem of constrained resource is to reduce amount of defective units produced. And number 6, add workers transferred from non-bottleneck departments. So most of the time, if you see in a factory, they have many departments. So let's say in one department there is a constrained resource. Maybe in other departments there are excess capacity. So the thing that can be done is ask workers from other department to transfer to the bottleneck department. Then maybe the problem can be solved. Okay, this is decision number 5. Joint costs. Joint cost is something like this. Okay, in some industries, a number of end products are produced from a single raw material input. 2 or more products produced from a common input are called joint products. The point in the manufacturing process where each joint product can be recognized as a separate product is called the split off point. So the thing is like this. In many businesses, one raw material can produce several types of finished product. For example, let's say Barrel's chocolate. The raw material is chocolate, and then after processing that chocolate, maybe they can produce more than one end product. For example, they can produce chocolate bar, chocolate drinks, and maybe chocolate cream. So one raw material can be used to produce more than one finished product. That is always happen. So if that is the case, two or more products produced from a common input are called joint products. And the point in the manufacturing process where each joint product can be recognized as a separate product is called the split off point. Okay, let's see this example. Okay, this is one example. The example is like this. The raw material is crude oil, or oil that just that a business got from drilling. So that is crude oil, raw material. From the crude oil can be processed and three products can be produced. The first one is oil, the second one is gasoline, and the third one is chemicals. So there are three products. So these three products are called joint product. The raw material is the crude oil. Okay, see the split off point. The split off point is the point where three products can be identified from one raw material. Okay, now the thing is like this. Okay, so the cost to process the raw material to become three joint products is called joint cost. So let's say you have this is your business. The cost to convert the crude oil to become oil, gasoline, and chemical, that cost is called joint cost. Joint cost, I will explain about that later. Okay, and then sometimes the product produced after the joint cost can be sold as it is, or can be processed further. For example, in this slide, you can see that oil can be sold as oil, or can be processed again and produce something else. The second thing is gasoline. Gasoline can be sold as it is. There is no possibility of process further. Chemicals can be sold as it is, or can be processed and produce something else. So the cost after the cost to process further is called separate product cost. The joint cost. See, remember the joint cost? The joint cost is the cost that you have to pay to process the raw material and produces several joint products. So that is the joint cost. Joint costs are often allocated to end product on the basis of the relative sales value of each product, or on some other basis. Although allocation is needed for some purposes, such as balance sheet, inventory valuation, allocation of this kind are very dangerous for decision making. If you remember about this, one thing that you have learned before is you have learned about segment reporting. Remember when you learn about segment reporting, fixed costs can be categorized into common fixed costs and segment fixed costs. Common fixed costs cannot be allocated, isn't it? So same goes like for this situation. If you have a situation a situation like a company has several joint product, the joint cost is like a common fixed cost. If you allocate the joint cost to the product, sometimes it can makes the it can make some products less profitable than it's supposed to be. So for this decision making, so for this decision analysis, remember joint cost is treated as a irrelevant cost. Joint cost is the cost that has been paid before. It will not affect your decision in the future. Okay, you will see that point later in the when you see the sample question. Okay, the decision is called sell or process further. Joint costs are irrelevant. Okay, this is the thing that I have said. Joint costs are irrelevant in decision regarding what to do with a product from the split of point forward. It will always be profitable to continue processing a joint product after the split of points so long as the incremental revenue exceeds the incremental processing cost incurred after the split of point. Okay, this is an example. When you see this example, I hope you can understand the decision of sell or process further. This is very simple. Sawmill Incorporated cut logs from which unfinished lumber and sawdust are the immediate joint product. Okay, see, the logs are the raw material. From this raw material, two products can be produced: lumber and sawdust. These two products are called joint products. Unfinished lumber is sold as is or processed further into finished lumber. Sawdust also can be sold as is or processed further into presto logs. So see here, this is data about sawmills joint product, includes this one. Remember, the logs is the raw material, and then the raw material can be used to produce two joint products, lumber and sawdust. If the business sell the lumber and sawdust as is, then the price is $140 for lumber and $40 for sawdust. If the business process the lumber further, and then the business will cancel the lumber that has been processed at $270. If the business process sawdust further and becomes presto logs, then the business can sell the presto log at $50. This is the allocated joint product cost. The allocated joint product cost is 176 and 24. Remember, the joint product cost is irrelevant, like I told you earlier. And then cost of process further. Okay, cost of processing further processing is like this. From lumber, if the business process the lumber further, then the cost is $50 per unit. If the business process the sawdust to make presto log, then the cost is $20. So now if you have to decide, the business has to sell the joint product as is or process further, then this is the way to make the decision. First, you have to calculate the incremental revenue, and then you have to calculate the incremental in cost. And then you will see which product is profitable to be processed further and which product is more profitable to be sold as is. Okay, see here the example here. The lumber, if the business sell the lumber, the price per unit is $270. And then, if the business sell the lumber as is, the price is $140, which is the sales value at the split off point. But if the business process further the lumber, then the new product can be sold at $270 per unit. So the incremental revenue, if the business process further, is 130. That is for lumber. The incremental revenue is 130. But the incremental in cost is 50. See the second column. The incremental in cost is 50. Now, the profit from further processing for lumber is $80. Why $80? Because the incremental in revenue is 130. Incremental in cost is only 50. So, the profit from further processing is 80. So, we can see here, for lumber, it is good to be processed further. Why it is good? Because if the business process further, then the business can get an incremental in profit of $80. A good idea to process further. But for sawdust, see here. For sawdust, if the business sells the sawdust as is, the value of sales at if the business sell as is $40. But if the business process the sawdust further to become presto logs, then the revenue or sales is $50. So it means that the incremental revenue of further processing is $10. And then you see there, the cost to process further is 20. Now, the incremental in revenue is less compared to the incremental in cost. So the business will make loss of $10. So for product sawdust, which one is better? Sell as is or process further? The answer is sell as is. Because if the business process further, then the business it will make loss of $10. So now you know the answer. For lumber, it is good. It is a good idea to process further, and then for sawdust, it is a good idea to sell as is. Thank you very much. This is the end of the lecture 1 for week number 7. I hope in the next lecture I can show you several examples or sample questions so that you can understand the methods that can be used to do several business decisions. Like I think 5 business decisions that you have seen in this topic. Do not forget to write your name and metric number in the comment section so that I will I know you have attended the lecture.